And these take about 3 or 4 minutes to cook on each side, and then you'll have to taste them, or taste a little corner of them if the potatoes aren't quite done. Cook them a little bit longer, or else you can finish them off in the oven. And you can make these either thick or thin, or whatever you like. There, I'm just going to let those cook for a little while. We're seeing how our gratin dauphinois is doing. Now those are small potato pancakes, and I'm going to show how you can make them as for a main course.
She would always use the French.
So based on those clips that I have, it shows how good this thing actually works on original parts. And although the picture tube is weak, it displays a picture decent enough that I think it warrants throwing some new capacitors and out-of-spec resistors in this set. So I'm going to take it apart, go through, inventory what I need, see what I have on hand, and I'm going to recap it. So here it is up on my bench. I'm going to do a complete recap on this set, and I'm going to just start by taking it apart and doing double checking what I need and ordering the parts. So I've got the chassis almost out of the case, and I got to tell you, this was extremely difficult to maneuver that out. The instructions that came in the Sam's folder tell you what to remove and how to take it out, but it doesn't tell you how to make that special angle so that you can slide this out and get the controls out of the holes that stick out the other side of the cabinet. And I also had to take the horizontal output and damper tubes out because they were pushing right against the side of the case. So ordinarily that would have been in the instructions. I got to take the high voltage lead off. I've used my screwdriver to arc out the tube so it don't jolt me. I'll do it one more time and then remove that. Here I have the chassis and for the DuMont. There are 18 paper foil capacitors to be replaced. 2 of them are pretty hidden down in here. Those are going to be hard to do. And the rest of these will be difficult but not impossible. If I counted right, I counted 18, but I'll be marking values down for a future order. Here are 3 electrolytic cans, plus there's an isolated electrolytic behind that's a one section that's not grounded. These two, one of these is a 4 section, the 3 section. They're all connected to the common to the chassis. I thought some people restuff those cans. I don't like to do that. I think that's a lot of extra work. I could be wrong, but you know, how often is somebody going to pull the chassis out to see that these look original? So I thought I'd take the cans out and just put terminal strips in and just put radial capacitors in their place but not inside the cans. To look at the schematic, but this isolated capacitor right here is probably part of the doubler circuit. And here are the 2 selenium rectifiers. One's behind this one. They're involved in rectification and voltage doubling. I don't know if I'm going to deal with those or not. I'll have to see how it works when I get it recapped by checking voltages. So at least 1 or more of these electrolytics are failing. I could see that in the picture. when I had a picture on the CRT with the vertical. I don't know which one of these is in the cans is part of the boost voltage filter and vertical circuit, but I'm going to replace them all. The question is how. Some people opt to cut the cans up and restuff them. That's possible. I don't generally do that. I don't see any reason to go through that trouble to clean them out and to restuff them. I think a lot of restorers like to keep it looking sort of original. But what I'm going to do is I'm going to come up with a system of terminal strips and just put electrolytics on terminals and connect these wires up to the appropriate terminals. That's my plan. So how I'm going to take these cans out, I'm going to cut the lugs, try to take all these wire connections loose, but I got to label the wires as I take them off. At this stage it's very easy to make a mistake. I have to double check my work, make sure that finally when I do get the other capacitors in that they're going to the right place, that they're the right value, and they're going to the right place in the circuit. C2 is a 4-section electrolytics and C3 is a 3-section electrolytic. So when I cut these wires off, I'm going to try to cut them off right at the lug of the capacitor. These interconnecting resistors, I'll have to deal with that somehow, but I have to label them so that when I put the new the terminal strips in and the new capacitors, that I have it all right. Either way, even if you cut the cans, to try to cut these cans, you'd really have to, you could maybe try hacksawing through them while they're in place. It's easier to take them off and cut them with a tubing cutter. That's a lot of work. So some people may not agree with how I'm going to do this, but I'm doing it, and this is the way I decided to do it. So I have C3 out. I marked all the connections. This goes to C3 triangle, C3 dome, C3 square. Here's another C3 dome wire here. The end of this resistor goes to C3 dome, and of course 2 resistors got freed up. One end was on C3 triangle and the other end goes to ground. This one connects between C3 dome and triangle. Here's where they establish ground to this circuit, is right here. This wire, this is a ground wire soldered thoroughly to this plate. They're not depending on the mechanical connection here to establish ground. So this, it's important to know this. This is where ground is. So when I put those terminal strips on, I definitely have to make sure that the ground of the terminal strips goes to this connection here. And here's where I'm at with it so far. I've got C1, 2, and 3 removed. The leads that go to C1, this capacitor is completely isolated from ground. They're part of the line coming in the doubler circuit. So I know that the plus is the white wire and the negative is the black wire here. I didn't need to you know, I don't need to label these because I know what they are. Everything else is labeled. The resistors are labeled according to where they went. So now I should be able to rebuild that circuit. So this C1, that's 140 at 200 volts, is actually part of the power supply. It's related to the rectifiers and the line coming in. So what I'm going to do is pull the 2 wires that were wired to this here, where this at one time resided, and bring them back into here, because I'm going to rebuild this section of the power supply. And what I mean by that, these are selenium rectifiers, and of course I do know that these are working because I've had the set powered up. The problem with selenium rectifiers is, as time goes by, They age, and there's a voltage drop across them. I don't know how long these would last. They lasted up till now. Some people, most rebuilders, opt to take them out and replace them with silicone diodes, which that's what I'm going to do. But the problem with replacing selenium rectifiers with silicone diodes is there's a greater voltage drop across these than there are with silicone diodes, a much greater voltage drop. So a lot of people that replace these, they'll put a dropping resistor, probably maybe something like a 5-watt resistor at 10 ohms, so that it keeps the B plus voltage down to the range that the set is supposed to operate on. I talked to somebody who rebuilt this exact same chassis. He replaced his selenium rectifiers with silicone diodes. He said that the voltage only went up 4 volts. That's negligible. It's nothing to worry about. So I don't see any problem in doing the same thing as he did, is just replacing them with diodes without a dropping resistor. Except, he also said he put in one of these. Now what this is it's actually a thermistor. They call it an inrush current limiter. So in other words, when these are cold, the resistance is quite high. And as they warm up, the resistance rapidly drops down. Now they never drop down right down to zero. There's always some resistance left in there. They don't go to zero. So this actually could compensate for the more efficient silicone diodes. I don't know. But this is what he said he put in. He put one of these in. There's another reason for wanting to put one in. The tubes in this chassis are all in series. So if one filament opens up, all the tubes will not light. They depend on each other because they're in series, that they light. And of course that's how the voltage between the filaments is divided. Now when you apply power and you apply all of the power right away, what happens is some of the tubes will light up quite brightly and then dim down. I know that on this set that's what happens with the pilot light. It lights real bright and then it dims down. This will probably eliminate that problem. And the reason you might want to eliminate the problem is because every time those tubes get that surge, the tubes that are closest to the line coming in could burn out eventually. On the other hand, these tubes that are in the set lasted a long time, so it's hard to say if they ever had that problem. But the inrush current limiter, one of these, should solve that problem. So I'm going to go ahead and rebuild this section first and then move on to putting in the new capacitors. So here's what I've done. Power comes in here, goes through the inrush suppressor, which is actually a thermistor, goes to the negative end of the 150 mic capacitor. The positive end of the 150 mic capacitor is at the junction of the two diodes. This is from ground up to the junction, and from the junction out to the B plus. So the B plus comes right out here. I'm very sure I got it right. I'll double check it a couple times before I ever apply power to it, but that's what I've done so far. This is the part that's always scary. I'm going to slowly bring the power up. I've only rebuilt the power supply with new electrolytics and modified it by replacing the selenium stack with silicone diodes. But bringing it up now, I got to see if this thing blows up or if it actually works. So let's see what we get. Not drawing much current. Nothing's popping or blowing up yet. Let's see, I'm at 108 volts. I must have bumped something. Maybe I tilted the yoke on it. I'll have to see if I can fidget that back into place. So anyways, the linearity is off, but notice that I've got pretty close to full vertical raster now, deflection, with just rebuilding the power supply. It's kind of out of focus. I got to look into that, see how I can focus it better. I don't know that there's a focus control on this or if it's just done on the shorting of the CRT pins. I'll have to take a look at that. But at any event, the power supply really fixed a lot of stuff on this so far. So this is about the best I'm able to adjust it so far. It still has a little bit of compressed vertical. That could be paper foil capacitors that I haven't changed out, maybe out of spec resistors, I don't know. But so far it's looking good. My power supply modifications worked real well. So I guess the next step is to probably start recapping it.